My wishes to respected Sir Madam. Our topic for International Conference on Industry 4.0 is a review on graphene and carbon nanotube with PLA composite feedstock filament for fused deposition modeling under Professor Prasanna Rao, Department of Mechanical Engineering, Saraswati College of Engineering, Kharghar, Navi Mumbai. This paper is basically concerned with evaluative study of various research papers to comprehend the optimum process and other factors parameters in production of composite feedstock filament of graphene and carbon nanotubes with PLA. The carbon nanotubes used here are multi-walled carbon nanotubes. This paper also studies the different approaches used and reviews on the methods, machines, processes used to obtain desired properties of the material. The objective of this paper is to recognize the properties imposed by the nanomaterials on the composite with different compositions. It will also provide the information on the effects of various processes and also the effect of 3D printers and the processes used on the properties of the composite material. Various approaches used and the different properties tweaked in order to have a boost in specific desirable property of material according to the application. For example, the application may be mechanical, electrical, or thermal. The need of composite. The need of composite is to produce a composite with desirable properties on higher level than compared to other composites. Like there are many other composites made from different materials, but they have properties which are not up to our desired. So it is to make a composite which can give higher level of properties as per our requirement. To obtain properties such as high tensile and shear strength with some electrical conductance in biodegradable material as PLA. To produce a material with high structural stability and chemical stability to be used in various medical applications. In medical application, various materials need to be having structural stability and chemical stability. So here the composites can be used. 3D printing processes. 3D printing process is actually an additive manufacturing process which has become a new option and has been increasing implemented for producing prototypes and components which are complex in shapes. Different 3D printing processes are fused deposition modeling, commonly known as FDM, stereolithography, SLA, selective laser sintering, SLS, and this one is new continuous liquid interface production, also known as CLIP. So the best and efficient economical method is FDM, fused deposition modeling. In FDM, filament is fed through the heated extruded head by arrangement of tractor wheel which deposits the filament by tracing a sliced layer to a CAD model. FDM is commonly suggested because it offers customization over its parameters like layer thickness, layer orientation, extrusion temperature, extrusion speed, nozzle shape and diameter, and support pattern also. The material used for the formation of composites are PLA with graphene and carbon nanotubes. PLA is polylactic acid, which is a biodegradable material. Graphene is a two-dimensional single layer of atom of carbon that are bonded together in hexagonal pattern. It is basically a single layer of graphite. It is very light in weight and stronger and sturdier in comparison to other materials. Structural graphene can be seen. The other nanomaterial which is used is carbon nanotubes. These are basically single layer of graphenes rolled into tubes. These are having high tensile strength and shear strength and are highly conductive for electricity. Applications. The composite can be used for the production of implants in biomedical sectors, like the implants we need when someone has a fractured bone or for supporting inside our body. As this material is having longer life and is light in weight, it is very useful in production of implants. The prosthetics used for various patients can be manufactured of this composite material due to its properties like high mechanical stability and light in weight. It can be also used for making scaffolds for tissue engineering. The nanomaterials can be bonded with other materials to get a composite for desired application in fields of aerospace, medical, etc. Conclusion. This composite shows greater promise than traditionally used composites. It is having high mechanical strength comparatively. It can also have high shear strength and high conductivity. Study of various process and parameter gives optimum method of approach for production of composite according to the desired application. If it is used for some mechanical purpose, the tensile strength and shear strength can be increased by changing the parameters and composition of the nanomaterials. Same can be done for electrical applications. It also enlightens the use of nanomaterial and widens the future scope for composite material. Graphene and carbon nanotubes are used on a great scale in today's industries and research fields. So it also widens the future scope for this composite material. Thank you.